Loop equations part 2, current and resistors and systems of equations. This video, there's going to be just a lot of reading, not a lot of writing here, and we will take several videos to hopefully flesh all of this out so that we cover what we need to. We first met Kirchhoff's loop equations some time ago when we were dealing with capacitors. Here we learn how to find unknown currents in complex circuits containing resistors by solving a system of equations. As before, for our loop equations, it won't matter which way we travel around the loop, at which specific point we start and stop. Furthermore, here, it also won't matter in what direction we assume an unknown current flows, and often we won't know which way the current actually travels. So we just have to pick a direction for our unknown current and stick with it, and we'll always get the right answer as long as we apply the rules correctly. A little more background before we get into actually doing one of these. When writing loop equations with resistors and assumed currents, if we traverse or pass through a resistor in the same direction as an assumed current, the voltage changes by minus IR. In other words, there is a voltage drop. What we have here are two things happening. We've assumed that there's a direction that the current is traveling. That's one thing. And then we are now going around the circuit, making a loop around. And if we happen to be traveling in the same direction that our assumed current is pointing, then whenever we go through a resistor, we have to go minus IR. On the other hand, if we are going around the circuit as we travel all the way once around the circuit, and we find that we are going through a resistor opposite to the way that we assumed a current is traveling, then we have to say plus IR. Hopefully, in the next couple of videos, we will demonstrate these things. A little more background, and then we'll look at an actual circuit. So here are the basic steps. We want to define only as many unknown currents as we absolutely have to. We're going to use Kirchhoff's junction rule to keep the number of these unknowns to a minimum. We'll show you that in a minute. We then want to traverse the same number of independent loops as we have unknown currents. However many unknown currents we have, that's how many loops we have to make around our circuit. We're going to use Kirchhoff's loop rule, and we're going to write one equation for each loop. And we want to make sure that every element in the circuit makes an appearance somewhere in one of the loop equations. So that's one thing. And each loop equation contains some quantity that no other loop equation has. And finally, we're going to solve the system of equations for the currents, and then we're going to make sure that we answer whatever question was posed. So let's look at this circuit. We won't solve it in this video. We'll solve it in the next video. We'll just lay out how we need to go about it here. Here's our circuit. We have two batteries, and we have three resistors. How many unknown currents do we need in order to solve this? What we're going to do is we're just going to start putting some unknown currents in here. Since the battery is directed this way, I'm going to guess that there's a current that is flowing in that direction. Now, we don't know that for sure, but we're just guessing here. That would be one current that's going through there. And perhaps on this side, since the battery is oriented this way, perhaps there's different current that's directed in that direction. I'm going to call that I2. Now look what happens. Around this left side, we have I1, 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 I1. Around the right side, we have I2 going this way, this way, this way. And now, do you see they join up right here? So we could say, oh, there's a current that's going through R2, and we could call it I3, current I3. But isn't it true that that I3, because we know about how currents flow through circuits, wouldn't that have to be numerically equal to what I've drawn here, I1 plus I2? What we're doing here, instead of writing I3, we're going to write I1 plus I2. That helps keep our number of unknowns to a minimum. So, how many unknown currents? 2. How many loops are possible? All right, well, There's a left loop here. So let me just kind of draw a little sketch. There's a left loop that we can go around, and then we could go around the right loop. So I'll draw that one. That's a second possibility. Or we could, if we wanted, we could go all the way around the circuit. We could do that loop if we wanted. There are a possible 3 loops to choose from, but we're only going to choose 2 of them because we only have 2 unknowns. For how many of the loops should we write an equation? Just 2 of these. So we'll solve this one in the next video, but that's kind of how we set this up.